The Keeling Curve is irrefutable evidence that carbon dioxide in the atmosphere is increasing.
So you can cope and you can cope and you can cope until some point you can't cope anymore. That's no way to run a government. That's no way to run a society. But that's what we face. So yeah, I'm Ralph Keeling, like art.
Welcome to When People Lead. I'm Jeff Rola. What happens when the data is clear, but the world isn't listening? Today I'm joined by Ralph Keeling and Art Miller, two scientists who have watched the climate change up close for decades. Let's get into it.
That carbon dioxide in the atmosphere is increasing and that humans are the cause. The Keeling Curve is irrefutable evidence that carbon dioxide in the atmosphere is increasing and that humans are the cause. The two reasons, or the reasons for each of those things are this, that Dave Keeling, Ralph's dad, basically was a very precise chemist, and his measurements are just, incontestable. And the fact that you're able to see this long-term trend in both, first of all, you see the seasonal cycle of carbon, and then the continuing increase since the observations were started, modulated by natural climate phenomena like El Nino and things like that. That growth in CO2 is irrefutable. The other thing is that if you look at the ratio of isotopes of carbon that are in those measurements, you note that the old carbon is increasingly becoming a larger fraction of that isotopic ratio. I believe that's called the Seuss effect. And over time, you could see that it's the increase in CO2 is due to old carbon being taken out of the ground and put into the atmosphere, not new carbon that's being recycled. So it's not a natural phenomena where the Earth system is just generating different types of plants that change and then produce more carbon. Hi, Jeff. I'm Dr. Art Miller of the Scripps Institution of Oceanography of the University of California, San Diego in La Jolla, California. I'm a climate scientist, oceanographer, and I also work with biologists to help them understand the marine ecosystem response to physical forcing. What I'm happy to do is just to share stories of my life and how they relate to the questions that you're planning to answer.
And full disclosure, Art is my brother-in-law. And so, Ralph, how do you feel? And tell us who you are.
So yeah, I'm Ralph Keeling, like Art. I'm at the Scripps Institution of Oceanography at UC San Diego. I also work on topics related to climate. I guess in training, I'm more of a geochemist, although did a lot of physics. So I ended up in the field very close to my father. He was the pioneer measuring the buildup of carbon dioxide in the atmosphere. The curve, Keeling Curve, is some of the audience may have heard of it. It's this rising curve of carbon dioxide. That's his curve that I have continued. I've also done measurements of similar compounds like oxygen in the atmosphere. All of this to try to track the big picture of what's happening with carbon dioxide and the human perturbation. Well, carbon dioxide has special properties. It's a greenhouse gas. It's the most abundant non-condensable greenhouse gas in the atmosphere, water vapor also being a greenhouse gas, but its abundance is controlled by the climate system, whereas the carbon dioxide has been being controlled by external factors like human emissions. So it's got very important properties that affects the climate. And the Keeling Curve was the achievement of my father's showing, in the early years anyway, this buildup. So it put the topic of modern climate change really to the public attention and to the attention of other scientists, and paved the way for the establishment of a research agenda and a community that's focused on trying to understand this problem. And today I'd say its importance is partly symbolic, and you look at it and you say, okay, we still have a problem because it's still going up. but it's also relevant for understanding just how fast it's changing and what we could do about it. My hope would be that at some point, with reductions in emissions, we'd see the curve start to bend, and so the curve could also at that point become a symbol, not just of warning we have a problem, but that we're starting to get control of it.
Yes. Art, how do you use that curve in connecting CO2 in the atmosphere, parts per million in the atmosphere, to the occurrence of more severe drought and flood and hurricanes, tornadoes, all of the other atmospheric weather-related issues that seem to be increasing as we go along?
That's a really good question, and it would require, probably an hour or two of explanations. But I'll do it in a simple way. The Keeling Curve is irrefutable evidence that carbon dioxide in the atmosphere is increasing, and that humans are the cause. The two reasons, or the reasons for each of those things, are this: that Dave Keeling, Ralph's dad, basically was a very precise chemist, and his measurements are just incontestable. And the fact that you're able to see this long-term trend in both, first of all, you see the seasonal cycle of carbon, and then the continuing increase since the observations were started, modulated by natural climate phenomena like El Nino and things like that. That growth in CO2 is irrefutable. The other thing is that if you look at the ratio of isotopes of carbon that are in those measurements, you note that the old carbon is increasingly becoming a larger fraction of that isotopic ratio. I believe that's called the Seuss effect. And over time, you could see that it's the increase in CO2 is due to old carbon being taken out of the ground and put into the atmosphere, not new carbon that's being recycled. So it's not a natural phenomena where the Earth system is just generating different types of plants that change and then produce more carbon. So one of the key features of carbon dioxide is that it traps more heat than it would normally. In fact, if we didn't have carbon dioxide and other greenhouse gases, our temperature on the Earth would be much, much colder than it is now. So in the stable environment that we sort of inherited after the ice age, things are such that we have a nice, comfortable planet that gets cold in the winter and warm in the summer, and it's a hospitable place in many ways. But with the extra CO2 being put into the system, more heat is able to be trapped through radiative processes that, again, would take some time to fully explain. Because the air has more heat, the air is actually able to hold more moisture. So that helps to explain why you can expect what we call an enhanced hydrological cycle. The atmosphere is able to evaporate more and hold more hold more moisture, say, for instance, taking moisture from the oceans and moving it over land and dumping it so it can rain more. But if the atmosphere happens to be dry in places over land, it can also absorb more heat from the land, so it can take away soil moisture and things like that, and also melt snow and things like that. So over time, you get an increase in the possibility for strong rainfall events, and also an increase in the probability of strong drought events for the very same reason. So that sort of ties back into your question of why CO2 is important. Changes in the variability of the atmosphere of things like tornadoes and things like that, those things are still being studied, and I wouldn't be able to just say, oh yeah, for sure this is going to happen because of extra CO2. But there are changes we call it changes in variance. How much does the system wiggle, right? There are certainly theoretical reasons and some observational reasons and some modeling results that support that you could have enhanced variance of things like storms, tornadoes, breakdowns in the polar vortex, things like that. But it's kind of dicey to say, oh yeah, that's definitely because of global warming, although you could make some persuasive argument.
Question. I mean, one point I'd make first off is that the polarization is pretty extreme, and it's to the point where mostly the people who don't want to think about this problem or don't think it's a problem don't even show up. So I actually haven't often been in a position that's confrontational because the people who show up and listen are the people who are interested in learning about it. But as to the question of, how do you make it persuasive? An important point is that the warming, the extraordinary warming we are experiencing now, and there's no doubt that we are in a period of extraordinary warming relative to the last thousands of years, really, really extraordinary warming. That was predicted based on very simple reasoning before it happened. We could see it coming. And so already in the 60s, there were pretty good, and even before that, 50s, in a way going all the way back to the Svante Arrhenius in about the 1890s, making a forecast of what might happen if we continued to burn fossil fuels. So it looked inevitable then, and it happened. Mm-hmm. And so it's not that the theory was cooked up to explain the warming. The theory was there, and then it was confirmed by the warming. Incredible ability, science achievement showing that this was going to unfold. So, that's one thing. You can also just appreciate just how weird the climate is today, just by looking around. Forests are dying in places they lived for thousands of years. They're expanding into the Arctic. There's bare ground that had ice on it for thousands and thousands of years. It's now being exposed by glacial melt. Sea levels rising at unprecedented levels. This decade is warmer than the last decade, which was warmer than the decade before that, and so forth. When did we have that happen before? Mm-hmm. No time in human history that we can point to. We're in extraordinary times. So people just need to wake up that big things are happening. And we basically aware of is the sort of the long time scale with which this is playing out. It's playing out kind of over the time scale of human lifespans or even beyond. And many societies and people and individuals have a livelihood that depends on the landscape, depends on the relationship to rivers and sea, the adjacent ocean and so forth, that are now under threat. And it's very threshold. So you can cope and you can cope and you can cope until some point you can't cope anymore. One of the key things about this problem is that once you realize you can't cope anymore, it's likely to be getting worse faster than ever. So it's going to be very hard to decide what you actually do at that point. So right now there's resistance, the New Orleans floods, and there's, we're going to go back and build the ground and build it back again. That makes sense for a generation or two. But at some level, that city has to look different. And so there'll be a break point. And so all sorts of, I don't mean to pick on New Orleans, it's a wonderful city, but it's in a bad spot now. And it wouldn't have been if it hadn't been for climate change. And there are all sorts of things all over the world that are now in bad places. And not just cities, it's whole civilizations, it's people who are making their livelihood off the land. They reach a break point, and then suddenly the whole ground isn't just that they can move to higher ground, it's that the higher ground is going to be under threat too. So it's really a difficult problem, and the solution, among other things, is just to get control of the pace of change by reducing fossil fuel emissions. So I want to make that point. What do we need to do as a society, as a humanity as a whole? We need to reduce our dependence on fossil fuels so that we can bring the emissions down. How do you do that in a political context where energy is so important for well-being? It's not easy, but embrace the energy transition, because renewables are fun and they're cheap. And so let's have a party with renewables. That's part of the answer.
And let's bring up New Orleans.
Yeah. Well, let me frame it this way. I mean, often when I give presentations, I show it's a science. I'm a scientist, so I give a science talk, and the questions are what to do about it. So the people who show up get that there's a problem and they want to know what to do about it. But that puts me in a bind, because that's not what I work on. I work on the problem. And as much as the problem needs solutions, it still needs people who are actually studying it, and so that we get the trajectory right and we really don't over-prepare or under-prepare. So my own focus is on that part of this community. And I appreciate very much the question about what to do about it, but I need to start with a caveat that that's mostly not what I work on. And I'm not apologetic about it, because society needs people like me. And here's the other rub, is that people say, well, the bad news doesn't motivate. We have to come up with good news. But I'm sorry, the news is grim. And I'm not going to put a silver lining on it just so that it can help policy forward. Our role as scientists is to be, just unfettered as much as we can, unfettered purveyors of knowledge and facts. And so if we stick to that mantra, our role is not to put silver linings on the science; it's just to convey the science. And I hate to say it, but we are in a bad place, and we're moving into worse ground faster than ever. That's where we are right now. And as much as humanity has taken measures to reduce the problem, we haven't turned any major corner yet, except in the attitudes of people. And that has to translate eventually into larger actions. And how do we get there? It's dicey because, different people are afraid of different things going forward. And climate change is not the only thing that scares people. People are scared about other things. And a lot of fear is a big motivator, and it certainly has been in the last
millennia.
Administration. Yeah. Well, yeah. That's one of the big issues here. So another twist on this to put it in perspective. This is an international problem, right? So the U.S. is now, I think, less than 15% of global carbon dioxide emissions. We own a much bigger share of cumulative emissions in the sense that we've produced much more than 15% of the problem today, probably more like half. But we're not what's moving us into bad territory fast anymore. It's the rest of the world and us together. So the solutions have to be international if they're going to actually have teeth and get things done. So how the international community works together to recognize the problem and work on it is super important. And I guess what's happened in the last year or so under this administration is very discouraging from that standpoint, because we're disengaging with the kind of international conversations that are going to be essential for moving this forward. So that's really, what can individuals do? You can't do a hell of a lot. Individuals can't make a heck of a lot of difference without support at really the level of governments and international cooperation. Technology waves can come through and make a big difference. So that's the easiest ground is to say, okay, we have new technologies, let's go with that. And that's why I emphasize that, because that can be an individual choice as to what kind of car you drive and your lifestyle in relation to energy use. But that's not going to move the needle in other countries unless there's similar sentiments there. So it becomes an international conversation. And ultimately, the renewables should be empowering all over the world. People don't want to rely on petrostates for their well-being. So renewables provide a path to self-reliance and independence. So they're a source of freedom that the world should embrace.
When they're monitored, don't seem to amount to much. But there are small steps that are going on right now where, there's more things like balcony solar, for instance, where urban areas where the electric grid is being consumed by other things, where they can put solar panels on their balconies and run their apartment on it. Some of the things going on from war that are coming out of Ukraine are looking at strategies that create that. So what I'm trying to drive is we have the science telling us X. And so, like the people who come to your presentations, what should we do about it? And there's no simple direct answer to that, but renewables are definitely part.
The thing, you can look to other countries and at least see that a lot of other countries are succeeding at reducing their greenhouse gas emissions and switching more to renewable energies. I mean, China is now leading the way, from what I hear, in solar. Right?
They still mine a lot of
everything
coal,
they can.
Yeah.
To stop things. Of course, they still burn a lot of stuff too, but they're also leading the technological surge that we need. Right? So there is hope by looking at even nefarious countries like China in terms of the fossil fuel burning, right? They're doing positive things more so than we are. So, there's hope out there. There are some models, I think, for success. But whether or not we band together as a global community to address this problem is unclear because of selfishness of the individual, selfishness of the corporation, the ability of corporations to control people with false media, misleading reports, and things like that. But Ralph and I are scientists, and in sort of an analogy of a newspaper, we're the reporters, right? We're just saying what's happening, and we can explain what's happening through a variety of things, through making the direct observations, through theory, and through running models to show how things actually are functioning. And we report that, right? Then there's sort of the editorial part of the newspaper analogy, right? We don't necessarily write the editorials ourselves, but there are some people who are really strong advocates for changing behavior in our society. And, we do that a little bit, like Ralph was pointing out. When people ask that question, we try to come up with positive news in a gloomy environment. But it's hard for us because that's not what we spend all our time doing. We don't, at least I don't read every possible new technology and master the understanding of that stuff, right? But there are people out there who are doing that. And all of a sudden, innovation hits and things change. We, hopefully in the coming decades, fusion will start working for energy, and we can switch that way. But of course, the whole infrastructure of that will probably take decades to build anyway. But the idea of using wind power and hydroelectric power and things like that, that's important, as well as solar, right? So we need the infrastructure, and we need leaders to take us there.
Yeah, well,
so
and
let's work together.
Back on is that yes, your science is showing that we need to do something about climate change, but your science also helps us decide where and how to plant and grow food. Your science tells us where we should go fishing. Your science will tell us how much road salt we're going to need next year for the blizzard that we expect. Those are the kinds of things that people can grasp every day and understand that that what the same indicators that farmers use that your data is providing, that information is also telling us we need to adapt to climate change, and that's somewhere where I think we can get out of that polarization, where people can connect with those things, as well as the fact that, hey, look, we're growing too fast. We're heating up the world too fast, and we need to do something about it tomorrow or yesterday. Art, you were going to say something.
Well, now that you said that, I'm going to point out that when you study the climate system, there's a lot of extra benefits that come from it, like you just mentioned, like understanding, topics that are related to management issues, such as fisheries, water management, and things like that. So, not just the long-term climate stuff that we're thinking about. We're thinking about helping to build better prediction systems for weather forecasting, right? But you still need to make those same measurements that will later on become part of the entire climate record, or will immediately be merged into the climate record as these weather events happen. And not just weather, but every other aspect of the Earth system, including, the ice in various places around the globe, the ocean state, and terrestrial ecosystems, everything. So there's a lot of good that comes out of it. And if you try to suppress the science because you don't like climate as a concept, and you're afraid of it, or you just want to squelch any knowledge of it because you don't believe in it for convenience, you would.
I was under the impression that the Hawaii site, there was a different site that was operating for a period of time that had to be closed down because of funding. Are there other monitoring? Are there other monitoring sites that you would like to develop to further flesh out the data that you're getting, or is Mauna Kea sufficient to continue what's going on?
Yeah, a little history there. So in late 2022, Mauna Loa erupted along a rift that was southeast of the observatory. The observatory is not quite at the top. And that lava flow from that eruption cut the road and the power to the observatory. So we had no data and no access to the observatory for a while. I should point out that the observatory is not run by the Scripps Institution of Oceanography. It's run by our good colleagues at the National Oceanographic and Atmospheric Administration, known as NOAA. It's a NOAA observatory, and we collaborate with them to get CO2 measurements there. They also make their own measurements, so there's a partnership there. When that eruption happened, we were all cut off from the observatory, and we scrambled to put in a second observing system on nearby Mauna Kea, which is the other big volcano on the Big Island of Hawaii. It's the one that's famous for having astronomical observatories on top of it. Some people
in the ski industry.
So we worked with the University of Hawaii that ran. Anyway, so we've kept the Mauna Kea instrument going since December of 2022. The power was restored, but not the road to Mauna Loa in 2023, based on the NOAA folks scrambling with extraordinary effort to install, using helicopters, sufficient solar panels to run some subset of the instruments, and the CO2 instruments were prioritized, so we kept them going. So we even though the road is still cut and the power is still cut, the observatory is still up and running based on helicopter support and solar power. There are many other observatories around the world that are measuring carbon dioxide. So this is really the most detailed and longest record, so it has incredible value, but it doesn't stand alone. We're measuring CO2, and when I say we, I mean a larger community of NOAA and Scripps and international partners is measuring carbon dioxide at dozens of stations around the world, also with airplanes, and there's satellites that are starting to measure CO2 well enough to have meaningful ability to look at differences from place to place. So there's a constellation of efforts going on at this point. I remember, the countries that lead in science, the world leaders, are countries that take on grand challenges. And they're not just thinking about, what can we do to boost economy in this area, that area. You bring in people, the best and the brightest want to work on the big challenges of their era. And they're attracted to countries where there's support for working on those kind of challenges. And that community of expertise is so beneficial, not just for that narrow problem, but because suddenly you have a fervent exchange of ideas. Silicon Valley grows out of this kind of fervor in the science of the Bay Area in the 1950s. So it's an incubator of all sorts of intellectual development that benefits a country. And a country that abandons grand challenges is going to abandon leadership. And climate change is one of those grand challenges. And it inspires people to come and work on big problems. And those people aren't just working on climate. The same people are working on weather forecasting. They're working on all sorts of other ideas that benefit society. But if you take away a grand challenge, the talent's going to flee to other countries. And the U.S. is going to really get punished for that. That plays out.
Are we training climate scientists sufficiently and in sufficient numbers to help realize some of the goals that we've been talking about to reduce the curve?
I think so far the U.S. has done well, but I mean, you see it already. I mean, we were bringing in postdocs and graduate students from other countries in significant numbers, and these people would often stay here because of the opportunities that it presented, and that conduit of talent is slowed down a lot in the last year, and I hope it's temporary. But even that 1 year will have consequences down the road.
No.
So we don't want to become a pariah state.
Okay, go ahead.
Yeah, I would just comment also that the funding streams that support PhD students in all aspects of Earth system science which includes the climate system, the ocean, ice, and ecology and humanity, right? A lot of those funding streams are being, strangled, and it's delayed and, changed so that people can't extend offers to postdocs and visiting scientists and PhD students. So I know this year there's been some real issues with the number of admitted PhD students being down because the money just isn't being released, even though it might be poised to be released. It still slows the system down, and it's an annual cadence of being accepted around by April and then starting in the fall in PhD programs. So if you just interrupt that, you can really disturb the system.
A lot of your work, Art, has been in training those students for tomorrow. The energy you bring to it, and the fact that you get up every day and do it. And can you just leave me with, why do you get up every day and do this? I'll start with Ralph.
Well, I got into this business not because I wanted to save the world, because it looked like a fun problem. So I get up every day and I work on it because it's fun. I mean, it's challenging and it's depressing in ways when you think of the big picture, but the day-to-day is fun. I mean, it's fun to work on a big problem. It's fun to work on something that people notice about, care about, and it's got its ups and downs. It's got its challenges. There's still new frontiers, new things to measure, things that haven't been done before. There's a landscape of opportunity, and embracing that and enjoying the process. That's what gets me up, keeps me going. So, I mean, people don't like to hear me say this, but I didn't get into this business to save the world. I mean, I care about the world, and I'm happy to see this data and everything in every way possible to help society as a whole. But personally, that's not why I got into it. I got into it because I was inspired by other scientists, including my father, who were showing what an interesting life it was to be a scientist.
I feel the same way. I mean, I still pinch my butt every day when I'm walking along the beach in La Jolla thinking, I made a career in science, thinking for a living and trying to understand the oceans, the atmosphere, the ecology. And to work with scientists who are also doing the same thing. We just love discussing those things, trying to understand systems better. And I also, like you mentioned, I do take delight in mentoring the next generation of scientists and helping them find their career paths in all different directions, all different types of science. I've had PhD students doing things. It's incredible. And the other thing I really like doing is talking with people who genuinely want to know what's the situation. I mean, even those who are embedded in the media of climate denialism, and that might be somehow part of their belief system. But when they ask me things like, well, is this global warming real? I don't start saying, ha ha. I say, oh, well, what do you understand about it? Explain to me what you know. And then I'll give you, I can tell you more if you'd like to hear it, but I'm not going to try to twist your arm and make you believe it, make you understand it, make you change. But if you want to hear, I'm willing to explain. And oftentimes that opens up the door for a conversation on the topic that I can help, give them, maybe undermine some of these falsehoods that they've been inundated with throughout their lives in whatever place that they live, and they're in their tribal communities that all want to think the same way and believe in the same concepts, right? So, breaking those chains to misinformation.
Art, thank you both. What I keep coming back to is the weight of the evidence. 5 years of data, the Keeling Curve, a planet speaking. The question isn't whether we know, it's whether we act. If that resonates with you, act on it. Links to Ralph and Art's work are in the show notes. This is When People Lead. I'm Jeff Rola. Until next time, keep leading with people first.
Thank you for listening to When People Lead. If this conversation moved you, share it with someone who needs to hear it. Subscribe wherever you get your podcasts and leave us a review. It helps more people find the show. Until next time, remember, change doesn't wait for permission. It starts with people like you.